Okay, so let us now see the miscellaneous examples. There are 5 of them. The first 3 we are going to see tonight. So in this one, we are given the values of sin x and cos y. And it's also given that x and y both lie in the second quadrant. Then we have to find sin of x plus y. That means naturally we will have to use the angle sum formula for sine, which is sin x cos y plus cos x sin y. Now sin x and cos y are given. That means we now need cos x and sin y. And that's what we will find first. And in doing so, we will keep in mind that x and y both lie in the second quadrant. So let us first draw a small figure and see what that has to do with everything. That is x and y lying in the second quadrant. So these are our coordinate axes as usual, and we draw a unit circle centered at the origin. Let us first consider the angle x. What does it mean that x lies in the second quadrant? This means that if we put x in the standard position, in which its initial ray is the positive x-axis, then the terminal ray will lie in the second quadrant in this sense. This is the terminal ray. Well, this is not a very good circle. I mean, from this point of view, I can see that it's an ellipse, but you get the point. Okay, it's the unit circle. Note that this does not mean that x is this angle or this angle. X may be this angle as well or something else. The only thing that matters is that the terminal ray of x lies here. Now, this terminal ray intersects the unit circle at this point, and that point itself lies in the second quadrant. So the sign pattern of the coordinates of this point is minus plus. The x coordinate is minus and the y coordinate is plus. And the x coordinate by definition is cos x and y coordinate is sin x. That means sin x is positive. In fact, sin x is positive, you can see that. But cos x will be negative. So let's start the solution with this thing. Since x lies in the second quadrant, so cos x will be minus square root of 1 minus sin square x. So now we put the value of sin x minus, so squaring the given value, we get 9 divided by 25. Oh, and by the way, cos y is minus 12 divided by 13, that we will remember. So this becomes 25 minus 9 divided by 25, or 16 divided by 25. So that means we get minus 4 divided by 5. So that is our cos x. Next, just like that, we are going to find sin y from cos y, and like x, y is also in the second quadrant. So for y also, cos y is negative. In fact, it is negative. It's the given value minus 12 divided by 30. But sin y will be positive. Again, y also lies in the second quadrant. So sin y is just positive square root of 1 minus cos square y. So recalling the value of cos y, it is minus 12 divided by 30 square. That means this becomes minus 144 divided by 169. Now this is 5 to 25 divided by 169, its square root. So this is our value of sin y. Now we have found all the 4 values, so we can now go for sin x plus y. Hence, sin of x plus y is sin x cos y plus cos x sin y. Now sin x and cos y are the given values, and sin x is 3 divided by 5 and cos y is this minus 12 divided by 30, and cos x and sin y are the values we have found. What was cos x? Minus 4 divided by 5, and sin x, sin y is this one, 5 divided by 30. So we can write our denominator, which is the same here in both of these terms, 65, and this one is minus 36 and this one is minus 20. So minus 56 divided by 65. So that is the value. The next one is an identity that we have to prove. The miscellaneous examples usually are different. No two of them are usually similar. Prove that cos 2x cos x divided by 2 minus cos 3x cos 9x divided by 2 is equal to sin 5x times sin 5x divided by 2. Okay, so obviously we are going to start with the left hand side of this claim, You can start the solution by writing either LHS or you can write we have. I prefer to write we have, but you write whatever you feel like writing. Cos 2x cos x over 2 minus sin 5x times sin 5x over 2. So here what we are going to do is we will multiply and divide by 2. That way we will get 2 cos 2x cos x over 2 minus 2 cos 3x cos, oh sorry, what the hell did I write? I had to write this one here. See, this is how things go wrong. Yeah, sorry about that. Cos 3x cos 9x over 2. Yeah. But why did we do this? This is because we can now use the 2 cos A cos B formula for both of them. 2 cos A cos B was this. Is cos A plus B plus cos A minus B. You can see why. If you expand these things, you are going to get 2 cos A cos B. So that means cos A plus B. In this case, A is 2x and B is x over 2 plus cos 2x minus x over 2. Same formula for this one, but there is a minus sign. Minus cos 3x plus 9x divided by 2, and again minus cos 3x minus 9x divided by 2. Okay, so what do we get if we simplify these terms? 2 times 2 is 4, 4 plus 1 is 5. Cos 5x divided by 2. 4 minus 1 is 3 for the next one. Plus cos 3x over 2. This one, 3 times 2 is 6, 6 plus 9 is 15. Minus cos 15x divided by 2, 6 minus 9 is minus 3, minus 3x divided by 2. Okay, so now we use the fact that cos minus theta is the same as cos theta. So that way we next get this. Minus cos 15x over 2 minus cos 3x over 2. So these two terms cancel each other and we are left with this. minus cos 15x over 2. And now we also need cos C minus cos D formula. So let's try to recall what it was. Do you remember that we have a scheme for remembering these four identities? The scheme was this. If we had cos and cos, if cos is the thing, then the terms will be similar. Either it's cos cos or sin sin. We won't have mixed sin cos term. Mixed sin cos terms come only for sin. So here we will have either cos cos or sin sin, but which one? If we had plus here, there we would have cos cos, but we have minus, so both the terms will be sin. In other words, we have this. Cos C minus cos D is going to have two sine terms. Obviously, they are sin C plus D over 2 and sin C minus D over 2. But if you remember, there was a 2 of course is present in all the four formulas, but there is a minus sign also. That's what we have to use here. So that means minus, already there is a 1 divided by 2, and then another 2 will come. Sin C plus D, this is our C and this is our D. 5x divided by 2 plus 15x divided by 2 divided by 2 times sin 5x over 2 minus 15x over 2 divided by 2. Okay, so these two get cancelled and we have minus sin 5 plus 15 is 20. 20 divided by 2 is 10. Divided by another 2 is 5. And what about this one? 5 minus 15 is minus 10. Minus 10 divided by 2 is 5. But there is another 2. Is 5 means it's minus 5. Magnitude is 5 but minus 5. So we have this. Now sine of minus theta is minus sin theta. So that minus and this minus will give us plus. And that way we have our identity. You can end the solution by writing hence proved. Or if you have started with left hand side, then you write right hand side, and then again you can write hence proved. Let us see another one. Find the value of tan pi divided by 8. Pi divided by 8 is not a standard angle, but it is 1/2 of the standard angle pi divided by 4 or 45 degrees. So this is how we can handle this. We will have to use the double angle formula for tangent function somewhat cleverly. This is how we start the solution. We see that 1 is tan pi divided by 4. We already know this. But pi over 4 can be written as 2 times pi over 8. So this is where we use the tan 2 theta formula, which is 2 tan theta divided by 1 minus tan square theta. One minus tan square pi over 8. So if you now manipulate this equation, on one side you have 1 and on the other side you have this. This is equal to 2 tan pi over 8, or a little more rearrangement gives us tan square pi divided by 8 plus 2 tan pi divided by 8 minus 1 equal to 0. So we have got a quadratic equation in, or rather I should say, I should not say quadratic equation, but a quadratic expression. Expression means a relation. Yeah, relation is the right term. In tan pi over 8, if you give this tan pi over 8 some name, say if you call it y, then this is going to look like this. Next equation. Writing y equal to tan pi over 8, we get this quadratic relation, y square plus 2y minus 1 is equal to 0. Now you can find the y values by using the quadratic equation formula. So y equals your usual formula, minus 2 plus or minus, because this is b, 2 square minus 4 times a times c, c is minus 1, divided by 2 times a, 1. You know what a, b and c are that I am talking about here. Ay square plus by plus c equal to 0, that thing. Minus 2. So this will be 4 and minus minus will be plus. 4 plus 4 is 8 and square root of 8 is also 2 times square root of 2. And if you divide by 2, you get this. So there are two possible values, but there is one more condition that is there on tan pi over 8, and that condition is that pi divided by 8 lies in the first quadrant, and any angle that lies in the first quadrant has all its trigonometric function values positive, not negative. And that's why between these two values we have to choose only the one which is positive. One of them is in fact negative, and the negative one is minus 1 minus root 2. So tan pi over 8 or y cannot be that. Now we write that since pi divided by 8 lies in the first quadrant, y equal to this has to be positive. Thus, this will be the positive of this 2, which is minus 1 plus root 2 or root 2 minus 1. So that's the value of tan pi divided by 8. So let me just end this video here itself. Tomorrow we do not have and the other two examples that are still there that we will see in the next trigonometry video, that means next Wednesday. And tomorrow there is no upload. Day after tomorrow, that means on Friday, we again go back to calculus. So see you on Friday with that. Until then, this is me, Lucifer from A Mathematical Room. Have a nice day.